Exactly 13.8 billion years ago, there was no space, there was no time, there was no matter. And then, the universe emerged. In the very first fraction of a microsecond, a period known as the Planck Epoch, the universe was confined to a microscopic point of infinite density. At this extreme scale of energy, the classical rules of gravity and physics that we observe today completely break down. This diagram illustrates what happened next: cosmic inflation. Notice how there is no central explosion shooting debris. Instead, the grid itself is stretching. Space is expanding outward in all directions at a rapid exponential rate. As that expansion continued, the extreme heat allowed a process called nucleosynthesis to begin. Protons and neutrons crashed together. Over the next 20 minutes, they fused to form the first atomic nuclei, mostly hydrogen with some helium. By the end of those 20 minutes, the temperature dropped below the threshold for nuclear fusion. The baseline chemical ingredients for the cosmos were permanently locked in, and the strict physical rules governing how they interact were set in stone. For the next 380,000 years, the universe remained a superheated, opaque plasma. Photons, the particles carrying light, were trapped, bouncing endlessly off a thick fog of free-roaming electrons. In this early plasma, scattered electrons actively deflect incoming photon waves. But as the universe cooled, recombination occurred. Atomic nuclei captured the free electrons into stable orbits, clearing the fog. Light finally broke free, traveling unimpeded across space. We still detect that ancient flash today as the cosmic microwave background. That burst of first light confirms a massive transition. The rigid physical laws established in the first few minutes had successfully organized quantum chaos into stable, transparent atomic structures. Even though space was finally transparent, it was entirely pitch black. There were no stars yet to emit visible light. In the dark, an invisible gravitational scaffold known as dark matter went to work. It began pulling colossal, diffuse clouds of neutral hydrogen gas together, slowly forming a vast, intersecting cosmic web. Deep inside those dense gas clouds, gravity cranked up the heat and pressure. The core temperatures rose until nuclear fusion ignited. The first stars were born, colossal giants up to 300 times more massive than our sun. These giants burned millions of times brighter than our star, flooding the cosmos with intense ultraviolet radiation. This radiation stripped electrons away from the surrounding neutral hydrogen, burning off the remaining murky gas in a process called reionization. The pitch-black void had served its purpose. It was a rigorous gravitational gestation period that architected the physical layout of the modern cosmos, organizing scattered gas into the dense hubs where modern galaxies would soon form. Over the next few billion years, those early giant stars exploded and died, leaving behind heavier elements. Gravity continued to pull these materials together, merging small clusters into the sprawling, swirling structures of modern galaxies. Roughly 9.2 billion years after the origin of the universe, a specific cloud of gas and dust, a solar nebula, began to collapse in on itself within one of those spiral arms. At the exact center of that collapsing nebula, the pressure ignited a brand new, stable yellow star. The remaining dust and debris spinning around this new sun flattened into a rotating disk. Governed by the strict rules of gravity, the debris clumped together, gradually accreting into rocky spheres. The formation of the Earth is a direct output of the exact same thermodynamic and gravitational equations written in the first 20 minutes of time. The rules scaled down seamlessly from the cosmic web to a local rocky planet. For the first 9 billion years of cosmic history, the collective gravitational pull of all the matter in the universe acted like a giant brake pedal. It was steadily slowing down the expansion of space. We know space is expanding because of early 20th century astronomers who proved that distant galaxies are actively drifting away from us. This graph shows the rate of cosmic expansion over time. Notice how the line gently curves downward for billions of years, slowing as expected. But right at the 9.8 billion year mark, it hits a trough and dramatically curves upward. A mysterious phenomenon, which we call dark energy, began overpowering gravity and accelerating the expansion of the universe. To map this accelerating reality, We rely on advanced instruments orbiting high above the Earth's atmosphere. By capturing ancient light from the deepest edges of space, they're quite literally looking back in time. What they reveal is that today, at 13.8 billion years old, roughly 68% of the entire cosmos is made of dark energy. The physical universe is completely dominated by forces and materials we cannot see. Every atom in your body was forged during these exact epochs, guided by strict physical rules that emerged from a microscopic point of infinite heat. Those laws are still governing every moment of our existence, carrying us outward on a continually expanding wave of space. If you want to see exactly how those laws built the ground beneath your feet, hit subscribe and join us for the next episode on planetary formation.